Hello and welcome to another video. In this video we're going to be working on subsets. And this is one of the core algorithms that you need to know for these problems. And so this is going to cover the backtracking algorithm, where essentially you have an array of some stuff and you want to generate all possible permutations. And that's what we're going to be doing here. So essentially you can see that in this you can make all subsets. So by the way, to figure out how many subsets there are of a number, basically what you're doing is for every number you have the choice to take it or not take it, right? It's very similar to the problem yesterday, which was an easy problem. The code's going to be basically the same here, but essentially for every number you have the choice to take it or not take it. So for every number you have two choices, and you have n numbers. So the number of subsets is going to be 2 to the n. So here we're going to have 8 subsets, and so you can see that here. So essentially, let's walk through kind of what's going to happen here. So we're going to have our actual array that we're iterating through, and then we're also going to have another array that's like the subset we're going to be building. So we'll have that. And we'll have one final thing, which is like the result. So let's just say the result's up here. We can build all our subsets, essentially. Okay, so let's kind of walk through what will happen in just like an overview of our function. Essentially, our function, what it's going to do is it's going to choose to take one of these, then go to the next index, then take it, go to the next index, then take it, go to the next index. And then after you take it and recurse, then you take the thing out of the subset, and then you choose to not take it and you go to the next index. So essentially we try all combinations. So let's walk through what that's going to look like. So essentially we start here. We're going to say, okay, let's just take this number. So this will be like our current subset. So this thing, let's pretend it doesn't have an index because it's more like a stack. So here, we're going to choose to take the 1. So we'll put in a 1. Then we recurse. Then we're going to choose to take the 2. So we're going to take first, then not take second. You can do it the other way. You can choose to not take, then take. Either one's fine. Then recurse and choose to take here. Now we're out of bounds. So every time we're out of bounds, we're just going to take the subset we have and put it into our result. So this is like the first subset we made. So that'll go into our result. Then we recurse out. And now, basically what's going to happen here is once we chose to take, then when we recurse back to our original place we were, then we're going to choose to delete what we put in. So we choose to delete this. Now we choose to not take. So we're going to not take, and we're going to recurse again, and now we're going to have this thing. So this is our second subset. Then we're going to recurse back out. And we've chosen to take or not take this 3, so now we're going to recurse over here. And we chose to take the first time, so now we will pop and choose not to take. Then here, we will take, so we'll have a 3, and then we will be done, because we'll be out of bounds for the next iteration, so this will go over here. Then, so essentially we'll go here, we'll put it in there, then we'll come over here and delete it. Now we'll choose not to take. So this will basically be just the subset here, just the 1. And that'll go there. So now we're done with this section, right? Like we chose to take and then we chose not to take already. So now we will recurse back here. So the first time we were here, we chose to take. Now we'll choose not to take. So we won't take, so we'll just pop. Then here we'll choose to take. Remember, takes first, then not take. So we'll choose take. Then we'll take here. Then we will recurse, so we're done. So this is the next subset we build. Then we recurse back out here. Actually needed that. So we recurse back out here, then we will pop, then we'll choose not to take. So this will be the next one. Yeah, so we'll throw that in there. Then we come out here, so we chose to take and not take. And you can see that here, right? We chose to take and not take. Then we will recurse out here, so we chose to take the 2, so now we'll choose not to take the 2. So we will do this, then we will recurse over here, and then we'll choose to take the 3 and put that over here. And then finally we will so we'll go here, then we'll recurse back out again. Now we'll choose not to take the 3, and this is the empty set. So now we just have this thing. And this is essentially all the results. So you could see what we did is we chose to take everything, then we chose not to take the 3. Right? So this is take everything, this is not take the 3. Then we recurse back out to the 2. We chose not to take the 2. So we chose to take the 3 and not take the 3. Then we recursed out to the 1, and now we chose not to take the 1. So we chose to take the 2 and the 3. Then we chose not to take the 3. Then we chose not to take the 2 and take the 3. And then we chose not to take the 3, which is empty set. So that's basically the algorithm is for every index, you choose to take, recurse, pop, and then recurse again. Or you can do it the other way. You can choose to recurse, do some stuff, and then when you come back, then take it and recurse. So essentially, you have 2 iterations. And this will also preserve the order of your items, because you can see like in here, all the items are in order. So essentially, this is what we're going to build. We're going to build this function, and we're going to use 2 arrays. And this is really common. One will have our result array, or I guess this is a list. And the other one will be just like the subset that we're currently building that we're just going to be pushing and popping from. Okay, so let's do that. So let's add a couple of class variables here. So let's say we're going to have a list. This is very similar to yesterday's problem, almost the same. This is going to be a list of integer result and the cur, which is like our subset. We can call it subset. Okay, so here we'll initialize it all. So we'll say result equals new array list and cur or subset. I usually just use result and cur, but subset makes more sense. Okay. Now we're going to make our backtracking function. So this is just going to be void, and it's just going to take an index. Now we'll call this like I. So once we're done choosing our items, then we'll have a subset build, which we'll just put into the result. So we could say if I, we also need the nums. Okay, so if I equals nums length, then we've built our subset and we just need to put it into the result. So we can say result add, I believe. And we're gonna put in the subset, except we need to put in a copy. So basically what's gonna happen is if you have an array and you put it into a result, like let's say I have this array and I have some kind of like result nested array over here, and I put this into the result, but then I modify it later, then the one in the result will get modified. So you don't want to put this in, you want to put in a copy. So you want to make a copy, and then you can modify this guy later, and they're not affected. So essentially, that's what we got to do. So we can't just like add our subset here. In fact, I'll show you what's going to happen if we do that. So let's just add the subset for now, and let's see what's going to happen. So let's add it, and let's return. And then now, basically, for every single thing, we have a choice, take or not take. So if we take, we're going to say subset add nums I. Then we recurse. Looks like I misspelled it. So this will be I plus 1. Then we are going, oh, and we need to pass down nums as well. Then we're going to choose to take out the item. So this is going to be subset remove last, I believe you can use. So remove last and then recurse again. So if we actually do this and we call backtrack, and we pass 0 and nums and return the result, we should be able to see what we have printed, I believe. So let's try it. Yeah. Okay. So let's see what happens. Okay. So you can see the result is all empty arrays. Because what ended up happening is we put our subset in, but then we modified the subset later, and then at the end our subset is empty. So essentially we just put in our subset a bunch of times into the array, but then since we modified it, this points to the subset that we're modifying. So that's why you need a copy. So we just need to make a new array list, and you can just pass in your subset as a parameter, and then it makes a copy. And there we go. Okay, and so this function is, as I said yesterday, is the first thing you want to look for, like the first thing, I mean, this is kind of obvious because you're basically building all combinations, but essentially this is kind of like a brute force where you're just trying everything possible. The first thing you want to look for is when the constraints are really small. That'll tell you like your time complexity can be really bad in pass, especially for harder problems. Like if you have a hard with a constraint 10, like they're not going to give you a constraint 10 if it can be solved in like O of n. It's very rare. So that's going to tell you like look for a 2 to the n type of solution, which we have here. So essentially, at every single step, we have the option of taking or not taking the item. So that's O of 2 to the n. And then making the copy of the subset is basically constant time because it's only 10 items. So that doesn't really cost us anything. So it's just 2 to the n here. And our space. So our space, like we're using the subset to store the thing. So I guess you can say this is like O of n. So it's gonna be something like this. You might argue like, you know, you're gonna have to, like, every time this happens, you have to make a copy. So maybe you can even say it's like 2 to the n times n. But because n is so small, and this is honestly so small, this is like close to O of 1, and 2 to the n times n doesn't really matter because n is only 10. So, but yeah, this is a core function you need to know, the backtrack function, and this is my favorite way to do it, where you just have your result, you have your subset that you're modifying, and then every time you have a condition where you're done, you just take your subset and then you put a copy into the result. It makes things nice and clean, very easy to do, and you can use this template for all these combinations, permutations, subsets, all these things. You just change a little bit of stuff. Like you change what index you start at and what you do, but the core of the algorithm stays the same. So hopefully this was useful. If it was, please like the video and subscribe to the channel, and I'll see you in the next one. Thanks for watching.